You're on video. Say hi to the video on 3. 1, 2, 3. Hi. Okay. Hello, YouTube. Okay.
Hey.
All right, we're YouTubers. We're streaming. Right on. 3, 2, 1. Thanks. Okay, so let's take a look right here. We've got this thing called the reflexive property. Here's what geometry is all about. Geometry is all about proving things. Like, for instance, saying that, let's say I was looking at a picture of a duck. I could prove that it's a duck because it has feathers, it has a bill, it has a certain kind of feet, it waddles when it walks. There are things that I could say, I will prove to you that that's a duck. Yes?
Yes.
In geometry, we do a lot of that. Like, we prove that it's a triangle. If I was proving that it was a triangle, how many sides would it have? 3. Yep. So, these are properties we're going to use to prove that it's okay for us to solve equations the way that we solve equations. So we're starting with proving some stuff about equations. And we are going to use these properties to do that. Bueno, bueno. Hello, Gabriela Garcia. Here you go. You need one of these? Gabriela? No? Do you need one of these?
No.
Okay. Gabriela. Oh, this is for you, I guess. You must. Okay, I thought that person was coming to class late. Okay, we'll delete that from the video. Just kidding. Okay, let's take a look here, guys. We got this thing called the reflexive property. The reflexive property sounds like a duh. Any value is equal to itself. Let me give you an example. Hold up 3 fingers. Hold up 3 fingers. Are these two the same? Yes, that's the reflexive property. Everybody say duh on 3. Ready? 1, 2, 3. Duh. Reflexive property is if two things are equal. Okay. We move down to the transitive property. Let's relate. Somebody want to grab that? Thanks, man. You gotta hang it up and pick it up again.
Hang it up and pick it up.
This is such a great video.
Pick it up. Pick it back up.
You need a paper.
Put it back.
All right, let's forget about the phone situation. Let's come back. Transitive property. Here's what's up with the transitive property. Everybody hold up 3 fingers again. You're only going to do it on one hand, though, okay? My 3 fingers on my right hand, these 3 right here, camera, are equal to these 3 fingers on my right hand, my left hand right here, yes?
Yes.
Are my 3 fingers equal to the 3 fingers that you are holding up?
Yes.
Yes. So if these two are equal, and my left hand is equal to your hand, then my right hand is also equal to your hand. The fancy way of saying that is if A equals B and B equals C, then A equals C. It's kind of like substitution, like what you're doing in your regular 8th grade math class, but it's saying, hey, if these are both equal to B, then they are also equal to each other. Does this idea make sense?
Yes.
All right. A lot of people confuse the transitive property with this property we're going to call substitution in a minute. This red stuff right here is something that I added. Transitive property, when we use the transitive property, is when 2 different things are equal to the same thing. See what I'm saying?
Yes.
Like A and C are different, but they are both equal to B. So A and C are equal to each other because they are both equal to B. All right? Maybe you want to take some time to write down that red stuff. I'll sling a quick example up here on the board. No more of the plunking water noises, okay? All right, so here's our example real quick. So I'm going to try and, I don't need to spin the camera a little bit maybe. Right there in our example, guys, let's take a look. I'm calling this A. 5 plus 3 is A. A is equal to, 5 plus 3 is equal to 8. 8 is B. Yeah? C is 4 plus 4. 4 plus 4 is equal to 8. These are both B, yeah? So since both of these are equal to the same thing, they are equal to each other. So we can make this statement because of these two statements. That is the transitive property. Simon? Simon? Simon, okay. Symmetric property, watch. Look at my hands. 3 fingers, yeah? 3 fingers. Are they equal?
Yes.
Watch. Watch. This magic trick. Oof. Are they still equal?
Yes.
Hey, did you see it? That's sick. All right. The symmetric property says that I can flip it over and it's still true. Watch again. 1, 2, 3. Yeah, if you're not watching closely enough, you'll miss it. All right. Let's move on with our lives. Okay, additive property of equality. This is a big deal. You guys have been doing this since at least 6th grade. I wrote lessons on this for you in 6th grade. You probably don't remember hearing the words additive property of equality, though. The additive property of equality says that we can add the same thing to both sides of an equation. Like right here I added 3, and right here I added 3. So when you're solving an equation and you do that, we just know that we can do that. Like by now you guys have been solving lots of equations in the 8th grade, yes? You just naturally do that now. When you do that, in geometry you need to be thinking to yourself, why is it okay for me to do that? It's okay for me to do that because of the additive property of equality. That's the reason why we can do that. That's the law or the rule that allows us to do that. Quick question for you. Could I add 35 to both sides? Would that be okay?
Yes, ma'am. Yes. I mean, sir, yes, sir.
It would they still be equal?
Yes.
Yeah. Is it going to help me solve it? No. But the idea is that no matter what, I can add whatever I want to both sides, and it's going to keep it equal. We can also do that with subtraction. There is a subtraction property of equality. You're going to see that same guy on the other side. How are we doing so far? I've talked for a long time. I want to check in with you guys. We're like this, we're like this, we're like that. Okay, I see all your thumbs up in the air. Here's what I need you to do. I see a lot of a few thumbs sideways. Here's what I'm going to ask you guys to do before we move on to the subtraction property of equality. Take like 1 minute. Talk to the people around you really quick about these 4. Share what you understand. Be ready to ask me questions. 1 minute, go. Those 4, if you were not able to figure out what you were a little bit confused on those 4 in your conversation right now, which I hope you were, ask me a question. What's up? Are there any questions about those 4? Do we feel better about them now that we had a chance to talk?
Yes.
What's up? Okay, symmetric property, right? Watch. 3 and 3. If I flip them over, are they still equal? Yes. So like this one right here, the symmetric property would say, okay, please do me a favor, turn the voices off, guys, right here with me. Thanks. The symmetric property would say that I could do this. And that's okay. I can flip this thing over and they're still equal to each other. Awesome, great question. I appreciate that question. What other questions do we have about these properties so far? Beast mode. Okay, moving on. If you understood the additive property of equality, you already understand the subtraction property of equality, because it's the exact same thing, just subtracting. This person that wrote this, that's Miss Palmer, was working on solving that equation. Would it be all right for me to subtract 35 from both sides? It would. It would not help me solve the equation, but it would be legal. Like I would not go to math jail for doing that. You look so excited about that. Okay. Couple more, let's move it. Multiplication property of equality. Allows you to multiply by the same amount on both sides of an equation. Does that sound a lot like the additive and the subtracting property of equality? Same deal. Division property of equality. Same thing, except this time it's with division. Yes, good job reading the first word. Okay. Questions about those three, or we feel like we got that in the bag? Thumbs, got it, confused. Why am I in this class? I have no idea. Where are you at? Show me. What's that? All right. D'Angelo, you good, bro? Okay. Let's talk about one that confuses people. Jiminy Christmas. Go ahead, man. You got it. All right. I'm going to unplug the phone during geometry class. We don't have enough time already as it is. Okay. Let's not let that distract us. Let's come here. Substitution property of equality.
Dylan Sanchez, you need to go to the
The lineman hustle back, yeah. Okay. Enough with the interruptions. Let's come back. Let's get it. Substitution property of equality often gets confused with the transitive property. Here's what I need you guys to do. I'm going to put the substitution property of equality up here. I want you guys to look at the transitive property on the paper that you have in front of you, all right? We're going to see what's different about it. The substitution property of equality says that if x equals y, then x can be substituted in or replace y. So this says, how many different variables do we have here? Two. It says we can replace one with the other if they are equal. Let me give a better example than that. So that would be like, if I gave you this thing that's drawn in the box, what would I do with the 6?
Substitute in for x.
I would do this, and I heard D'Angelo say I would substitute it in for x. Notice the name of this thing is the substitution property of equality.
Yes.
Yep.
So this is not saying, hey, these two things are the same to the thing in the middle, so they must be the same to each other. This is saying I'm going to physically take this and replace something with it. See how it's different than the transitive property? That one's going to be a little bit confusing people, perhaps. The other thing about the substitution property, how much is 5 plus 3?
8.
8. This is the substitution property. I substituted 5 plus 3 for an equivalent value, 8. A lot of people want to call this combining like terms, especially when they have something like this. 5x plus 3x is 8x. We would say in math class that's combining like terms. The real rule for that is the substitution property of equality. I'm substituting this for something that has the same value. Yeah? So you'll notice on mine, I wrote think combining like terms. Or I should add or substitution, like what we have come to call substitution in the regular math class. I was hoping that was Delon coming back. That's cool. Okay. You're back. Good. All right. Awesome. If you want to hang out after school for like 2 or 3 minutes, I'll run you through these things. We'll get you up to speed. I want to make sure you feel comfortable before you get out of here at the end of the day. Cool? All right. Let's move on. These two, I get them backwards all the time, and I'm like way old. If you get them backwards, it's not that gigantic of a deal. Associative property says that if I have more than 2 things, like I have a 2, a 5, and a 7, and they're being added or multiplied, I can reorder the order that I do that. Like see how the parentheses are here? And over here the parentheses are here? Are we going to get the same thing?
Yeah.
Yeah. Because it's addition. We could also do multiplication with this. Yeah? We can put things in different order if we're adding them and they still come out the same. Like 5 and 3 is the same as 3 and 5. Yeah? Sick. Watch, I'll show you another magic trick in a second. All right. But this magic trick is one that doesn't work. Watch. 5 plus 3 is 8, yeah? Is 3 plus 5 8?
No.
3 plus 5 8? Yes. 5 minus 3 is?
5.
2. Is 3 minus 5 2?
-2.
Negative 2. So the magic trick does not work for subtraction. Because subtraction, what we would say, the correct mathematical way to say this is subtraction does not follow the associative property. Or subtraction does not have the associative property. You can't move things around when you're subtracting. Okay, guys in the back, you good? I know you love the magic tricks. Sick, huh? Okay, moving on to the commutative property. The only difference between associative and commutative is with associative we have 3 or more things. With commutative we only have 2. Why do we need a separate rule for that? I don't know. Cool? Here's how, I just thought of a way to remember because I have a hard time remembering which one is which one. Everybody say commutative with me, but we're going to say it like this. Ready? Commutative. Ready? 1, 2, 3. Commutative. Commutative sounds like two. I make the same moo noise, right? Commutative has 2 things that are being added or multiplied. Associative is the other one where there's more than 2. Muy bien? Muy bien. Okay, show me with your thumbs. Where are you on the back page? Up, sideways, down. Where are we at? Okay, I'm going to take like 30 seconds to look at what we're going to do next. I'm going to ask you guys to talk about the properties, ask each other questions, be ready to ask me questions when you come back and your marks get set. Talk. All right, I think we're ready for action. Back in 3, 2, 1. Thanks. All right. Questions that people have about the properties and stuff before we move on with our life?
1,300. Oh, wait.
Questions or we're good? I usually try to ask like 3 times because usually somebody has a question and they're a little bit chicken to say it. Please do me a favor, man. Control your body, yeah? Questions? One more time? All right, let's move on. We're going to be on this page right here. It's page number 3. We're going to skip all this junk at the top. We're going to get right to it. So, you might look at this and be like, hey, sick. They did the problem for me. Right? Don't you wish this would happen in your regular math class right here?
Yes. A lot.
Big time, right?
No, I like doing that.
Okay, a lot of times in regular math class when you're looking at a problem like this, you're looking for the person's mistake. There is no mistake here. They did this correctly. Our job is to justify why it was okay for them to do each one of these things over here, all right? So what's going to happen is I'm going to go through and do one. Pause for 1 second. I'm going to go through and do one. I'm going to ask you not to write anything. We'll talk the first one through. After I finish it, then you can write the things in, okay? I used to teach. I've gotten better at teaching, I think, over the years, and one of the things I've learned to do is to tell people, hey, when we're working on something together, don't write, because I want you to focus on thinking, not writing. I will give you time to write it, all right? So don't write. Let's just think, okay? First of all, we got to figure out what this person did. From here to here, I'm looking at it. The 5 is the same. The 7 is the same. That 5, that 4, and that negative 10 are not there. Now there's a negative 11. You guys with me? Yeah. Back here, guys? You good? Yep. Mr. Man back there with the hood? You with me, bro? Yep. It's totally cool. I don't care if you have your hood on. Just be with me. I care about your brain, man. I want it to grow. Okay. So let's right here. Check it out. This 10, negative 10, positive 4, and negative 5 all came together to make negative 11. We're not going to talk about how they got negative 11 because I think for this group that should be pretty self-explanatory. Let's just talk about which one of these rules or properties says that it's okay for us to do that. I'm going to go back to my example right here where we talked about 5 plus 3 is 8 and 5x plus 3x is 8x. Students all the time want to say, it starts with the C, combining like terms. Let me give you a clue. Combining like terms is not a property of equality. You cannot use that. If it's not on the sheet, you can't say it. Make sense? It's like going to a restaurant and saying, hey, I want to have a hamburger, but you're in a Mexican restaurant and they don't sell hamburgers. This is the menu, all right? You with me? This is the menu. If it's not, look for the video. If it's not on this list, you can't use it, all right? So it's got to come from this list. Commutative property is not on this list. What is where we wrote commutative property, though? This is like the commutative property. That's the substitution property of equality. Muy bien. And if you just want to write substitution, I would take it. Some teachers are real sticklers and want the word property of equality. I see people writing. I said don't write. Wait till the end. I'll give you like 30 seconds at the end to write. What I want you guys to do right now, right? We're thinking. You can write in a second. But when we're doing this, I want you to be thinking to yourself, do I really understand why we chose that property? All right? Do we really understand why we chose that property? Yes or no? Show me with your thumbs. Some people are sideways. Okay, let's talk about that property one more time. I stuck some stuff together, yeah? Like combining like terms. Substitution property of equality. Think combining like terms or substitution. We're either replacing something with something that's equivalent or we're combining like terms. Stick with me guys back there, please. Thank you, man. Okay, let's look at what they did from here to here. Remember, you don't need to write anything yet. We're not super worried about that. What I care about is thinking. You can write this stuff in a second. The x is still there. The negative 11 is gone. So if we were solving this equation, we would have done plus 11 and plus 11. I look through my sheet. The addition property of equality says that I can add the same thing to both sides of an equation, yeah? You with me, guys, yeah? And this is the addition. And I'm not going to write property of equality. Well, I will. Property of equality. All right. Remember, you don't need to write anything right now. I'm concerned about thinking, not anything else. So I see from here to here, what's gone? 7. They subtracted 7x over here. They subtracted 7x over here, and x minus 7x was negative 6x. That's a lot like the addition property of equality, but did we add?
No.
We subtracted, so subtraction. You can see I'm getting more lazy as I write, right? I'm abbreviating more. I think abbreviations are totally cool. You totally don't need to write all the words out, right? Big fat wasted life to do that. Okay. Now from here to here, they got rid of the 6's somehow. How did that happen?
Dividing 6.
They divided by negative 6. And so I divided. What's that going to be called? Division property of equality. See how I abbreviated them all now? That was totally sick, huh? 2 claps for abbreviating. Ready? 1, 2. That was kind of weak. We can do better than that for the video. Ready? 2 claps. 1, 2. All right, sick. All right. Do you guys want to take time to write that down right now, or do you want to move on to the next one and kind of work, give it a shot?
Move on.
Some people want to write. Okay, I shouldn't have even asked. That's my bad. That's a mental note for next time. Don't ask, Schlegel. Okay. I'm going to give people like 30 seconds to write those down, make sure they got them and stuff like that. Then we'll move on to the next one. Should have put on some music right now and make some pum 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 dun, 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 dun. About like 15 more seconds to get these things written in there. If you're writing super slowly, stop writing super slowly. If you're writing the whole word, start abbreviating. We only got 12 minutes. This class runs away from me super fast.
Wow.
All right, I'm going to ask you if you don't have them all written down, go ahead and pause with the pencil, and we're going to look at example 2 really quick. Can you guys tell I like teaching? I have a lot of fun with this thing. All right. Have fun with me. That means be quiet and watch and listen. Okay. Have you guys talked about the word given before?
Yeah.
You've done some proof junk in here? Let's talk about the word given really quickly. That's the only thing that was up here that we didn't kind of go over really fast. People might look at this one and they go, I'm supposed to have a reason, but nothing happened. This is where you started with, right? What I need you to notice right here is underneath example 2, it's telling you, hey, you are given that a plus b equals 2c, and you are given that b equals c. When you are proving things, you have to state what you were given to start with. Does this idea make sense?
Yes.
Yeah? Okay. So see the a plus b equal 2c? Do you also see it right here? Our reason is we were given that. They told us that in the very beginning of the thing. Remember, don't write, chill. This is the part where you get to chill and nothing else works except for your ears, your eyes, and your brain, yeah? We also have b equals c here, and I was like, okay, how did they get b equals c from this? I was confused. It was given to us, right? Would it be possible to get b equals c from this?
No.
No. It doesn't even, there's no way. So I would look up there, yes, it was given to us. Look, we only have 2 things to do. Save one. Okay. So I see a plus c equals 2c. That looks a lot like this one. You guys back there? You looking here? Right here. We're up there. A plus c equals 2c looks a lot like a plus b equals 2c. It's a slight little difference though, right? Why was it okay to put c here instead of b?
Because B equals C.
Because if B equals C.
Transitive property. Yes.
Is it transitive?
Yeah, transitive.
It's funny in the key right there it says, is it transitive or is it substitution?
Transitive. It's right up there on the board.
I think it's substitution, guys, because does it say... Okay, so let's do this, right? If it's transitive, we have to have 3 variables, or 3 things. We have to have an A, a B, and a C, right? Are there 3 things involved in this, or is it just 2 things, just B and C? Just B and C, so it is substitution. I found another cool noise right now. Say substitution with me, just like we said commutative, we're going to say substitution. Ready? 1, 2, 3. Substitution. So substitution only has 2 variables. What's up? I'm going to keep teaching through these announcements, unfortunately. Sorry, Mrs. Parch, I'm running out of time. It's geometry. This is a fast-paced class, and I can't keep up. Okay. So... They got A equals C somehow. How in the world did they get that?
That is a transitive property.
They subtracted C from here. They subtracted C from here. 2C minus C is C. A equals C. That is, what did we do?
Transitive.
We subtracted. So that's the subtraction
But if B
property
equals C,
of equality. Beast mode, Simone. Subtraction property of equality, because we subtracted C from both sides. I know this is a new way of thinking for you guys. You're probably going to wrestle with it a little bit. That's totally cool. By this weekend, we're going to have this video up on YouTube. If you get stuck, you're working at home, you can come back and look at the video on YouTube. Don't put anything away. We got 7 minutes. Here's what we're going to do. On the back side is exercises 1 through 6. Our goal is to get at least exercise 1 done today and cleared by me. Here's how you clear it by me. You work on it to start with. You work on it with your groups next. Then we get you have a representative from your group call me over, and I take a look at it, and I agree, or I tell you that we need to make a small change. Bueno? Bueno, 1, 2, 3, go. Time for teaching is over. Was a blast.